whose title is Basic Training on Odor Pollution. This workshop is organized within the D-NOSES Horizon 2020 project. And the idea of this workshop was to provide to the D-NOSES participants, and not only, because this will be made available through the streaming and the olores.org YouTube channel, an afternoon of discussion and of presentations with the basic principles of odor pollution. Who was here this morning has heard Rosa talking about the D-NOSES project, which is a project on citizen science, and the project has within, among its participants, some odor experts, but some others who are not odor experts. So we thought it would be a good idea to involve the odor experts who are here at the conference as speakers to try to give some basic concepts regarding odor pollution. So this is the program, and that we will discuss. And I will start with a presentation introducing the basic concepts about odor perception and odor measurement. Well, since we are a little bit late, maybe I will go a little bit quicker about the part on odor perception, since it has been also presented very well during the conference, but I will still try to give the main basic concepts. So first of all, what is an odor? The definition of an odor is that an odor is a property of a mixture of substances capable of stimulating the olfaction sense sufficiently to trigger a sensation of odor. So it's really a question of perception. The odor perception starts in the nasal cavity and ends up with the transmission of a stimulus to the brain. And what is so special about odors is that they involve the higher parts of the brain. So that's why odors are sometimes able to provoke emotions or souvenirs in people. And sometimes also physical reactions because of the involvement of the trigeminal nerve. You can think of unpleasant odors that really cause a physical reaction, or of like peppermint odors, which may cause you to have also a physical reaction. Human olfaction, well, in general, olfaction is a primal sense for humans and for animals. From an evolutionary standpoint, it is one of the most ancient senses. Nonetheless, it is one of the less studied up to now. And one demonstration for it is that a Nobel Prize has been won by Richard Axel and Linda Bach in 2004, so not a long time ago, because of their studies about human olfaction. So this gives you an idea of how recent the studies about human olfactions are. However, it is one very important sense for humans, involving almost 3% of our genes. So a significant part of our genetical code is dedicated to olfaction. And this again gives you an idea of the importance of this sense for human life. I don't want to become too technical here. As I said, I will try to go quickly, but at least you have this information. What happens when we perceive an odor? Everything starts in the upper part of our nose, in the so-called olfactory epithelium. That is an area that for humans has an area of about 5 square centimeters. This area is much bigger in dogs, for example, who have as you probably know, a much more developed sense of olfaction. So it's sometimes really a question of area dedicated to the perception of odors. When volatile organic compounds are inhaled through the breathing, this come into contact with the olfactory epithelium and especially with the sensory cells that are in the epithelium. These can cause a series of enzymatic reactions. I'm not a biolog, so I will not go into the detail because I don't even know them. But what happens is that there are a series of enzymatic reactions resulting in the depolarization of the cell membrane, which causes an electrical signal to be transmitted to the brain. As we have seen, one interesting thing is that we have about 1,000 different types of receptor cells. So 1,000 different types of receptor cells, each of which is capable of reacting differently to different substances. As we had, it is if we had like 10 different sensors in our nose, 1,000 different sensors in our nose. Each receptor type is sensitive to several odorants, and each odorant is sensed by multiple olfactory neurons. I highlight this because this is a very important concept, especially concerning what we will see this afternoon regarding electronic noses. Our receptors in our nose are not selective. We don't have a specific receptor for ammonia and another specific receptor for H2S, for hydrogen sulfide, or for specific molecules. Each receptor type is sensitive to different compounds, and different compounds can stimulate different receptor cells in a different way. What happens is that there is a first degree of mapping which happens already in our nose, because each of these receptor types, which are distributed randomly within the olfactory epithelium, all converge to a type of cell called glomeruli, and each receptor type converge to the same glomeruli. So depending on the type of glomeruli that are activated from a certain odor, you can already have a sort of first mapping, of first odor fingerprint of an odor. This gives you a first pattern of response across the multiple glomeruli, which gives a first codification of the olfactory quality. This is all electric signal. Here, this all happens in the nose. So from there, the signal goes to the brain, and there is where the odor is effectively recognized, elaborated, and compared with a database of what we've learned during our life, and which makes us able to recognize an orange odor from an apple odor, or from other types of odors. So it's really a sense that involves different levels from our nose to the higher parts of the brain. I won't say more about that because I think it's important that we go on in seeing how odor can be characterized. Odor can be characterized through different components. The main components that can be used to describe an odor are the odor threshold, which is connected to the concept of odor concentration, the odor intensity, which is also connected to the concept of odor concentration, but which is not the same, and the two things should not be confused, which sometimes happen. Then there is odor diffusivity, odor quality, and hedonic tone. And we see briefly what these different components are. What is odor threshold? Odor threshold is the minimum concentration of an odor substance in order to provoke a given stimulus in humans. Odor thresholds are usually expressed at 50% or 100%, depending on the percent of people that perceive the odor. So you can have the odor threshold at 50% is the odor threshold at which 50% of the population are capable of perceiving that odor. Moreover, it is possible to define three different types of odor thresholds. The first one, the lowest one, is typically the odor detection threshold, which is the concentration at which an odor is first detected. Detected means that you are able to say, oh, yes, there is something different from neutral air, but it's not strong enough to make you recognize what kind of odor it is. For that, you need a higher concentration, which is the odor recognition threshold. So not only you are able to recognize that there is something different from neutral air, but you are at a level of concentration for which you are capable of recognizing what type of odor it is. And getting up with the concentration, we can reach the so-called odor annoyance threshold. So you not only detect and recognize an odor, but you are annoyed by it. So this is another type of odor threshold that can be defined. One important thing to highlight here is that odor thresholds are not additive. So you can't just take different compounds with different odor thresholds and sum them up. Olfactory properties are not additive. So odor and odorant mixtures cannot be defined by simply summing the effects of its single components. There are synergic effect, masking effect, but the basic concept is that odor is not additive. And that is a very important concept for what concerns odor measurement, as we will see later on during this presentation. About odor detection thresholds, there is a lot of literature, and different values of odor thresholds can be found in literature. The problem with the odor thresholds that you can find in literature is that they are not always very univoc, meaning that depending on the source that you're choosing, you might have differences of orders of magnitude. And that's of course a problem, because it's not so easy to define the odor thresholds. I reported here two examples. One is a paper of no, it's not of 1979, I'm sorry, it's 2012, this paper, but here you have the the link to the paper, the link to the paper where you can find the table, and you can see that here there are, just as an example, there are a lot of different sources for that, a list of chemical compounds with the odor threshold, and also a short description of the type of odor. This extract is from the regional guideline of the region of Lombardia. We are in Milano, region of Lombardia. We have a regional guideline about odor pollution, which was issued in 2012. In the fourth annex of this regional guideline, there is the possibility to carry on chemical analysis is mentioned with the report of some odor threshold. These are experimental ones determined in our lab at Politecnico. And this is just one example of odor threshold for compounds which are expressed in PPBs. We will discuss that later. But another important concept that I was saying before is, another important concept is concentration, which is the concentration of a compound which is multiple of these odor thresholds, which has not to be confused with intensity, which is a measure of the strength of the odor stimulus. So of course it is connected to concentration. The more one odor is concentrated, the more the stimulus that it causes will be strong and thus intense. There are different laws that describe the correlation between odor concentration and odor intensity. These are two examples, the Stevens law and the Weber-Fechner law. Typically you have a threshold concentration under which odor is not perceived at all, so intensity is 0, and above which intensity begins to grow, not linearly with concentration. Intensity is usually described with the descriptor in a scale. This is an example from 0 to 6, where 0 means that the odor is not perceivable, whereas 6 means that the odor is extremely strong. What about diffusivity? Well, the concept of diffusivity is also important because, as we discussed briefly before about odor perception, to be perceived, an odorant molecule should be able to reach the human nose, otherwise it will not be perceived as an odor. So its volatility, its capability to volatilize in the air is of course a concept of crucial importance to make an odor perceivable. So it is possible to define what is called an odor index, which is the ratio between the vapor pressure, which is an index of the volatility of a molecule, and its odor threshold to describe this parameter. Typically, alkanes and alcohols with low molecular weight have odor index in the range of 10 elevated to 5, which is low, whereas mercaptans, which are very odorous, have odor index that reach values of up 10 elevated to 9. What about odor quality? Well, odor quality is something complex because, of course, defining odor quality involves a very high degree of subjectivity. What can be done to try to define odor quality is to use some kind of odor classes or odor descriptors. Of course, the type of descriptors that you will be using depends on the type of odor that you are characterizing. This is an example of a study we published 4 years ago about the qualitative characterization of gas odorants. You know that methane is typically not odorous, and it is made odorous for safety reasons. So if you leave the gas in your kitchen opened, you are able to perceive that because it has a strong odor. It is an odorant that is added for safety reasons, so it will not explode if you forget to leave the gas open. And qualitative description of this kind of gases can be done by using some descriptors, and in this case, descriptors that were used to describe the quality of gas odorants are strong, intense, unpleasant, how much unpleasant it is, sulfuric, pungent, irritating, chemical, rancid, sweet or Swedish. What does this graph mean? When you want to describe the quality of an odor, you have a panel of people that are asked to give a score from 0 to 6, for example, the same scale that we saw here, for example, to each one of these descriptors. So you smell the odor and you have to say how unpleasant is it in a scale from 0 to 6, how sulfuric is it for you in a scale from 0 to 6, and by scoring each one of these descriptors, you are capable of giving a description of the odor quality. Other similar methods are the odor wheels. You can find odor wheels for different types of odors. It comes originally from the food industry, but it has also been applied to the environmental odors. This is an example, a proposal of odor wheel for composting odors. So it's a typical example of environmental odor. And this is a graph I took from the VDI 3882, which is the German guideline on the determination of hedonic odor tone, which is different, we will see it later, but there is an example of, of how you can describe the quality of an odor. Here you see different descriptors, strong, weak, coarse, fine. Of course, these are each row has on one side one descriptor and on the other one its contrary. And so also here you see that you have to evaluate from 1 to 7 to give a score to each one of these descriptors to characterize an odor. And here you can see, for example, the characterization of stench and thiophenol, which have very similar profiles on this scale of descriptors, which means that the quality of odor, the quality of the two odors is perceived as similar, whereas for stench and peppermint, the scoring of each descriptor is very different, thus indicating that these odors have very different qualities according to this way of describing them. And then finally, the hedonic tone is the last of the parameters which is worth mentioning. As I said before, there is a guideline, a German guideline, who describes how to measure hedonic tone. There is a well-defined procedure on how to select the panel of people to carry out this kind of measurements. Without getting too much into the detail, the important thing is that the hedonic tone is the measure of the pleasantness or the unpleasantness of an odor. And it can be rated in a scale that goes, according to the VDI 3882 part 2, in a scale that goes from +4, which is the score for an extremely pleasant odor, to -4, which is the score for an extremely unpleasant odor. And in the middle, you will have all other possible degrees of pleasantness or unpleasantness. What I would mention here is that here we are dealing here with odor pollution, so with environmental odors. And there has been some discussion about if it's worth including evaluations of hedonic tone to differentiate in case odor impact criteria. Well, it's a complicated task, this one. It's true that independently from the pleasantness or unpleasantness of an odor, if an odor is perceived for a prolonged time, it can become the source of an annoyance even when it is pleasant. So in the case of environmental odor pollution, also pleasant odors have to be taken into account because they can be a source of annoyance. So now let's move to the problem of odor pollution. Well, odor pollution is quite a big issue now because if we see what happens with the local authorities, at least here in Italy, but as far as I know also elsewhere in Europe and elsewhere in the world, odors are nowadays, among atmospheric pollutants, the major cause of population complaints to local authorities. So people are they tend to complain mostly about odors more than to particulate matter, basically because they don't perceive it. That is the reason. The reason for that is that several conventional pollutants, many of them also harmful for human health, are not perceived by the population, and so they don't complain about that. Whereas some odors that have so low odor thresholds that they can be perceived also at very low concentration, and so also when they are below normal exposure limits, and that causes people to perceive them and people to complain. And so that is the reason why they are a cause of complaints. And we are here because, of course, this is a problem for different for the society. One other complicated task is the relationship between odor pollution and health risks. Of course, what happens is that citizens are often worried about the fact that when they perceive an odor, they are afraid that this odor might be harmful for their health, so that the odors may involve a health risk. It should be said that this is generally not the case. It's not always true, but it is generally not the case. So, of course, it is important to keep in mind the relationship, the possible relationship between odor emissions, odor perception, and health risks. But it should be also kept into consideration that nature made us well, in general, meaning that we are able, as humans, to perceive harmful substances at concentrations that are far below the concentration that become harmful for our organism. This is, of course, true for many substances, not for all of them. If you think about benzene, It's a substance that has a very high odor threshold, but it is cancerogenous. So this is an exception, for example. But if you think, for example, of hydrogen sulfide, which is very harmful because it can be lethal for humans, it has a very low odor threshold, and so we are typically able to perceive it at a concentration that is 3 orders of magnitude lower than the so-called threshold, time-weighted average threshold limit value, which is the level of concentration at which a worker can be exposed for all his life. So it's not a short-term limit. So this is another important aspect of odor pollution. However,
can we ask questions?
Yes, of course you can.
It's this issue about health and odor. I think, as the World Health Organization says, it's health is not the absence of illness. It's a clear state of mind and well-being, a general well-being. So being annoyed or causing nuisance, it affects the health, even though it's not something physical. It could be something mental. So I think when we, and there are, it's established in the literature, some papers on that subject. So when we are trying to relate health and odor pollution, it's true that very low concentrations we perceive it, and it's not directly affect our health, physical health, but it can cause problems.
Absolutely, and that's exactly the next slide, telling that it's not just a question of getting sick, meaning that you must have cancer from the odor, which is hopefully not the case in most cases, but that the presence of odors, even if it might not involve a direct toxicity, let's say, of course it affects negatively, in some cases very negatively, the human well-being, because you are not able to profit of your terrace in summer and have barbecue with your friends, or because just you are it's an unpleasant odor that causes you nausea or headache. These physical reactions exist. This is nuisance, and then of course odor, in this case, it becomes some kind of a health issue, or at least a well-being issue. And so that is the reason why we are here discussing about odor pollution, because this becomes a problem even when there is not a direct toxicity. So there are different reactions, as the anger, irritation, and whatever. Not only, I think I wrote it in the next, that is the reason why, of course, there is a need to regulate odor impacts, and to, if you want to regulate an odor impact, this means that you have to be able to measure it somehow. And we will come later to the methods for odor impact assessment. There are a lot of chemical substances coming from a variety of different activities that may originate an odor problem. I don't have time here to list them all because it's an infinity, from waste treatment, wastewater, refineries, livestock, and whatever. And as I said before, even pleasant odors can be a problem. So chocolate factories may become a problem as well. And there are, and what is important to understand is that environmental odor emissions are generally not emissions of only one compound, but it's generally very complex mixtures of tens or mostly hundreds of different compounds. These are just examples of compounds that can be found in atmospheric emissions, but it's really a reduced list because it would take the whole afternoon just to mention all the chemical compounds that may be responsible of another problem. And going back to odor annoyance, as we said before, The annoyance, what is odor annoyance? Annoyance is complicated to define. It is the complex of human reactions that occurs as a result of an immediate exposure to an ambient stress, or that causes negative cognitive appraisal. It depends if the perception of the smell is negative, if it is repeated, if it is difficult to avoid the odor, and if the smell is often incorrectly, but it is connected to a negative effect on health, that as I explained a few minutes ago. There will be a presentation this afternoon trying to explain the different factors, the so-called fiddle factors, that are connected to odor annoyance. What is important to say is that it is also possible that there is an effect of sensitization of the population. So a population that is repeatedly affected by some kind of odor, that might become sensitized to this type of odor, and so become even more sensitive to this type of odors. Or you can have also a phenomenon of adaptation, which is exactly the contrary, which means that after a while you don't perceive the odor anymore. So it's very different how individuals can respond to odors. Finally, the last part of the presentation, I will have to go very quickly. It's about odor measurement. I will give just an overview because Andrea after me will go a little bit more into the detail connecting the odor measurement techniques to the legislation. First, odors is connected to perception. So measuring odor is a complicated task. It is because it entails the problem of objectifying a sensation, which is not easy at all. And this must be clear. We are talking of something that is not banal and that should not be banalized. It should not be banal. So to measure odor, it is necessary to have specific techniques and to follow specific protocols. It is not something that can be done in a rough way or in an easy way, unfortunately. Historically, the most important, the first way that was used to characterize odor is chemical analysis. Chemical analysis is, by chemical analysis I mean gas chromatography and mass spectrometry. Gas chromatography allows to separate different components and to identify the single substances of an odorous mixtures. And if you are good enough and you have the right standards, you can not only identify which substances are present in an odorous mixtures, but also quantify them, which is complex, but it is also possible. That is, of course, a very useful information in a lot of applications, but unfortunately, these have not time for getting too much into the detail. But the important thing to understand is that once I've identified and quantified all the single substances that compose an odorant mixtures, this doesn't give me necessarily an information about the odor properties. Because as I said before, odor is not additive. So I cannot just sum up the odor of ethanol and pentane and styrene and whatever, put them together and come out with an information about the odor property. This is unfortunately not always possible. Odor is not additive, and more, sometimes odor is caused by substances that are present at so low concentrations that chemical analysis might not be able to identify them. So this might be an additional problem. So, okay, chemical analysis can provide useful information, especially in the case where the odor is caused by a limited number of compounds, but in most cases, for environmental odor, it is not able to provide information about the odor properties. We have heard this morning some presentation about gas chromatography coupled with olfactometry. This is something a little bit different, which provides to couple gas chromatography with with a sniffing port, which means that the compounds are separated, and that at the end of the column there is a sniffing port where a panel can associate to each peak another description. And this gives a parallel chromatogram and olfactogram, which might be a little bit different because it depends on the odor threshold. There might be components that are very much abundant in quantity but that have low odor, and vice versa. You can have compounds that are very low in quantity but that have high odor, and have as an output also the classification of each peak. So, as I said before, the drawback of chemical analysis is that it is not directly correlated to the odor sensation provoked in humans, and that is why sensorial techniques which use humans as a sensor have become so popular, and this is the field of olfactometry. So olfactometry relies on the use of examiners, of qualified people, qualified selected people, which give information about the sensation that is provoked directly on them by an odor. Dynamic olfactometry is the most common one, and it is the technique that is used for the determination of the so-called odor concentration. Odor concentration is expressed in odor units per cubic meter, and to make it easy, it is the number of dilutions with neutral air that is required to bring an odor sample to its odor detection threshold. So imagine that you have a sample that has to be diluted 1,000 times to make it unperceivable by the panel. This means that this sample has an odor concentration of 1,000 odor units per cubic meter. It's a little bit simplified, but it explains the concept well enough. If you have a stronger odor, a more concentrated odor, that needs to be diluted 1 million of times to make it not perceivable by the panel, then it means that it has 1 million of odor units per cubic meter. There is a European norm, the EN 13725, that regulates the execution of olfactometric analysis, and this is very important because, of course, when you talk about sensorial analysis, people sometimes associate sensorial analysis with subjective analysis. This is not true, or at least not always true. If you follow the standard, this subjectivity can be reduced to a minimum, and you can still have an objective measurement also if you are using people to measure them. So even if you are relying on a sensorial technique. How is the olfactometric measurement carried out? You typically use an olfactometer. This is just one of the examples of the methods that exist, but basically you have a sample that is diluted at the beginning so much with neutral air that nobody is able to perceive it. And then progressively you concentrate it until the panel starts perceiving a difference between the sample and the neutral air. And so the concentration at which the odor is perceived is registered, and this becomes the odor concentration of the analyzed sample. Of course, as I said before, the European norm helped in standardizing and gives some criteria for accuracy and repeatability. So that's important to say. Dynamic olfactometry is not subjective. It can be an objective measurement, although, of course, it is characterized by an uncertainty which is typically quite high. So you should not be surprised when you hear about uncertainties of about 50%. It's okay. It's typical of this kind of measurements, but still it can give you an important information. What is the problem with dynamic olfactometry is that dynamic olfactometry quantifies odor concentration. The quantification of odor concentration is made at the emission sources, so you are able to quantify how much concentrated an odor source is. For example, the output of a chimney, okay? But of course, this information is not sufficient to give an information about the impact on the citizens. So how much are the citizens affected by this source? To do that, you have to evaluate citizens' exposure, and that's a quite more complicated task. Dynamic olfactometry is not sufficient alone. You should be able to directly to quantify in some way the exposure, and measuring odor is in the field, despite a certain simplicity of measuring at the sources, is really, really complex, and we will see that now. One possibility is to use mathematics and to apply odor dispersion models to the information gathered through dynamic olfactometry. So what happens is you measure, quantify a source by not only measuring its concentration, but at least by combining the information about the concentration with the odor flow rate, the air flow rate. Because of course, if you have the same odor concentration associated to a flow of 1 cubic meter per hour or 100,000 cubic meter per hour, the amount of odor that you are emitting is completely different. So what you use is typically odor emission rate, which is the product of the odor concentration and the odor flow rate. You combine it with the meteorological information, and this is the input to a dispersion model. Dispersion model that can give you an information of how the odor emission disperses into the atmosphere and reaches the receptors, the citizens. This is a very popular approach because most regulations currently are based on dispersion modeling. You will see that later in the workshop. In many cases, limits can be expressed in a maximum odor concentration that may only be exceeded, for example, for 2% of hours in the year. Of course, the criteria depend from region to region, from state to state, but this is an example of principle for the applicability of odor dispersion modeling to odor impact assessment. And this is a typical map resulting from an odor dispersion model with the concentration lines. In this case, the outer line is the line corresponding to 1 odor unit per cubic meter, which means, in this case, at the 98%, that would mean that at this line, the odor concentration of 1 odor unit per cubic meter is exceeded for 2% of the hours in a year. This is just an example. But odor dispersion models are very popular. They work pretty well. We can discuss for hours about which is the best model, how to apply them. There is a full scientific subject behind that. But what we can surely say is that odor dispersion models are not always applicable. First of all, we are always talking about models, and models are not reality. That is the first important point to keep in mind. But also, in order to apply dispersion modeling, you should be able, besides having reliable meteorological data, but let's imagine that this is possible, you should also be able to characterize sources in a very precise way. And this is not always possible. There are diffuse sources, of course, which are hardly characterized. One of the main research topics in our lab is trying to characterize diffuse sources, but we are able to characterize some of them and some others not yet, at least. But there are also sources that are impossible to characterize for the simple reason that they are not continuous and that they are variable with time. If you think, for example, of pharmaceutical industry, one day they produce one product, the week after they're producing something different, and each production can be associated to different emissions in terms of flow rate and of concentration. So if you have this case, what do? Applying a model can become really, really complex. So in that case, it is important that you are able to measure odor in the field, in some way to directly assess the odor at the receptors. How? Well, about that, there is a lot of discussion. How can it be done? Again, one possibility is to use the chemical analysis to measure the presence of one compound in ambient air. This can be done by science with the sensors, for example. This is an example of a measurement of H2S in ambient air. Fine, but you have to be sure that the compound that you are measuring is strongly related to the odor that you are looking for. So if you know that for your type of odor H2S is the main component, the main tracer, then it's probably okay to measure continuously the H2S concentration. But otherwise you will have an information about the H2S concentration but not necessarily about the odor. So it's very effective if the odor that you are looking for is composed by one compound only, or if this is a compound that is very highly correlated to the odor concentration, which is really not very often the case, unfortunately. Otherwise, another possibility is to use electronic noses. Electronic noses, we have seen this definition 100,000 times, is an instrument with the electronic chemical sensor with partial specificity and the pattern recognition system that are capable of recognizing simple or complex odors. We will talk about that later this afternoon. But basically, these have the advantage with respect to dynamic olfactometry to be continuous. They can be placed directly at receptors and measure odor continuously, at least ideally. That's what they should ideally be doing. Ideally, electronic noses should be able to continuously or repeatedly analyze the ambient air directly at receptors, so at the homes of the people that are complaining about odor, to detect if the odor is present or not, first of all, and if they're trained well enough, also to recognize the odor, and so to classify it, and for example to recognize if it's the odor from a biofilter or if it's the odor from fresh waste, or in the cases in which you have multiple sources, you can have an electronic nose capable of recognizing if the odor is coming from a wastewater treatment plant or from livestock, for example. So not only detecting the odor, but also recognizing it. Another technique that is possible to use to measure odor in the field is field inspections. Field inspections are still based on humans, so it's not instrumental, but it's based on the use of a human panel. In this case, we are talking, it's not citizen science, it's trained people. So it's a panel of people that are trained and selected. These people are typically can typically do measurement in fixed points or follow some precise paths to identify where the odor is perceived or not. For that, there is a European norm, the EN 16841, which was issued at the end of 2016, which was inspired by a German guideline again. And two methods are distinguished, the grid method and the plume method. I won't go too much describing that, but it's quite different methods for determining odor impact in the field. The advantage of this kind of technique is that they allow a direct assessment of the odor exposure in the field, but they are often expensive. Another possibility, of course, is to use also the resident populations. So there are also some regulations that foresee to distribute questionnaires, for example, to the people, to the resident population, and to collect their odor perceptions. This is the case, for example, in the region of Lombardy. The guideline in the region of Lombardy in Annex number 3 describes a procedure for evaluating odor impact based on questionnaires that are distributed to the resident population. VDI 3883 does, I think, almost the same, but we will hear about it later on this afternoon. The problem with it is that you have to deal with the subjectivity of the people involved in the surveys, which are sometimes not very objective, maybe because of their personal involvement in the odor pollution situation. So to conclude this overview on odor measurement methods, and especially in odor measurement in the field, approaches based on chemical measurement have the advantage of being easy and reliable, more reliable than the measurement of low odor concentration. By dynamic olfactometry, you have to keep in mind that it's not written so explicitly, but you have to keep into mind that the detection limit for dynamic olfactometry is reasonably around 50 odor units per cubic meter. Below that, you have really difficulties in distinguishing one sample from the other one. However, the identification and quantification of odor tracer compounds by chemical analysis is not always correlated to the odor perception, as I said before. For this reason, chemical analysis is only successfully applied in the rare cases where the odor emission is characterized by one single compound or by a reduced number of chemical compounds. Another possibility is to, as I said, evaluate odor exposure at receptors with social participation, so with collecting and analyzing complaints data and one-shot surveys concerning local residents, or questioning resident panelists on repeated occasion, or asking them to complete odor diaries regularly. There are a lot of experiences proving the efficacy of those methods, and also the positive psychological effect of involving the population and make them actively take part to the assessment of odor impact. But of course, the drawback is their subjectivity, and also by experiences and opinions. If someone is highly stressed by an odor, his perception might really become not very objective. I don't know if we had some experiences with this kind of surveys, and they're sometimes very complex, because even if you ask people to compile odor diaries, what you get is questionnaires in which they write, when you are lucky enough, not insults, because this happens as well, but in which they say odor is perceived from morning to evening continuously, and describing any kind of bad odors. So it might become unreliable, so you have to really be able to process the outcomes of this kind of surveys very carefully, in order to exclude outliers or unreliable responses. This can be partially overcome by running field inspections with a trained panel of people, according, for example, to the two methods foreseen by the EN 16841. Especially the first method, the grid method, has the drawback of being rather expensive, because we are talking about surveys that last 6 months, 1 year, which involve a certain number of participants who must go out and register their odor perception at any time in the day and in the night. So we are talking about surveys that might become very, very expensive. On the other hand, the plume method is less expensive, but it gives a very partial information because it only allows to evaluate the extent of an odor plume in a certain condition. And so it's just a partial information. Also, electronic noses can be successfully applied for odor impact determination in the field. They can be used both for detecting and recognizing odor. The great advantage of electronic noses with respect to all other techniques involving people is that they, being instruments, they can be used for continuous analysis. So this is the big advantage. But honestly, for those of you who were there on the first day of the conference, Santiago Marco explained very well which are the limits and the difficulties associated with the use of electronic noses, and there are a lot of them. Starting from the sensitivity of the sensors, which are normally not so sensitive as the human nose, and also to the high number of interference connected to the use of electronic noses with other atmospheric variables like humidity, temperature, and so on, which affect the response. So also measuring odors with electronic nose sounds very attractive, but it's really very, very complicated. So it must be done with a lot of attention. And I finished, I'm late already. So I would leave the word directly to Andrea and leave the questions to the end of the 3 presentation of this first part of the workshop.